So hello, everybody. So yeah, today we're going to speak about using streaming for IPA and sometime how you can have like stateful IPA using string at the same time and make that easy, you know. So yeah, as been said before, my name is Duzan. I live in south of France, as you can say by my accent. I live in Toulouse. You can find me on Twitter, and outside of work, I'm used to unicycle, and now I'm more into biking.
Yeah, hello. My name is Matthieu Baechler. I do exactly the same thing, backend engineer at Conduktor, a long time, free software enthusiast and advocate. And you can find me on Twitter for as long as Twitter exists. Yeah, so we are working at Conduktor, as said. Our goal is to make Kafka, which is a very technical component, reachable to other kind of people, not only developers, but also business people, testing people, business, I already said, and so on. So we try to make it high fidelity. So what is high fidelity to me? Is first best UX you can do, and best UX is best discoverability. It means that if you know something exists in Kafka, it should be easy to find it in our tool. Also, we optimize for precision. Precision is data that we show has to be accurate and up to date. We will see that it's quite important on the design we will propose later. Finally, dev tools have to be fast. Like I don't want as a developer to have a tool get in my way. I want it to be fast. So optimizing for latency is something important for us.
So yeah, now let's give some context. So let's speak about Kafka. So I'm wondering how much of you have used Kafka for work or are using Kafka currently for work? Okay, I see a lot of hands. And how many of you already know about Kafka? Okay. So I'm going to go a bit fast on that. So as you all know, I guess Kafka is about like scaling massively. So you can have easily like 1,000 topics, like 100,000 of partition. And it's really fast at publishing and consuming messages, you know. But there is something where it's not really fast. It's about giving metadata about it. And it's why at Conduktor, we do tools for that, you know, to help you. And so here, so we have a platform, and one of the main part of the platform is consoles with the dev tools that allow you to explore what's going on in your Kafka cluster easily. So you can like see the consumer groups and the topics. So the first page used the most often is the topic list, where you can see all the topics you have in cluster, and you can directly see the most important metadata about the cluster, so the number of partition or the number of records on your topic, you know. But so that looks simple, you know, but in reality it's not that simple. So here you have a representation of all the call we need to do to Kafka with the on the admin API they provide. So each square is a call, you know, and an arrow represents like dependency. So as you can see, there is a lot of call we need to do just to display those data. Some call can be done in parallel, some can't, so you have to be smart about that. And also sometimes like Kafka API allow you to say, okay, give me data for a certain number of topics so you can go fast. But if you ask for too much at once, the request will just time out. So I have to be smart about that, and we found like you have to do like batch of 30 elements. So
let's explore solution to do web API for that. So we are using GraphQL at Conduktor a lot. So the first thing, the most obvious one, is to ask for every properties you need to display the screen we saw before. So let's do just that. You do the request, you have all the data there. Here is the code. Quite simple. You list topics, you list broker IDs. When you have some data, you can chain with other requests. It's just typical Zio code that everybody probably knows how to do. It's not specific to Zio, but every I/O library. The problem with that is latency. you don't have anything to show to your user unless you have all the data. So it can be a bit long, and it's not a very good experience for your user. So what can you do next? Next solution is, oh, I have GraphQL. I can craft 2 different queries. I do a first one with the fast properties. I can compute them fast, so I can display them as soon as possible, like the topic names. People will just start looking at the names of things, and then they will get the other properties. So you have a perceived latency that is much better, but at the same time, it can make the full runtime, overall runtime will be longer because maybe you have more things to compute because maybe you lost some properties between the 2 requests, and there's a round trip with the server coming in the middle. So overall, it can take longer. Third solution, the Restful way. Restful is about exposing things as resources. The good thing is that you can build a web application that just asks for things in parallel, and as soon as we have a response for a property, we can fill the screen with this property. So in terms of latency, is good. In terms of execution, is probably not so good because the backend will probably get too many requests at once and maybe have to compute things twice and things like that. So it's not so good in terms of overall runtime. If we put that on a scale from lower latency to higher latency, you'll see that it's coupled with the overall runtime somehow. At one end, we have Restful. In the other end, we have GraphQL single request, or it could be of something else than GraphQL, but it's single request. And between, we have trade-offs. So there is a lot of way to make trade-offs. But it also pushes the logic about what is fast, what is not fast into your front end. So your front end developer will have to care about whether it's fast to have the names of topics in Kafka. And maybe it's true in a version of Kafka, maybe it won't be true in the next one. So yeah, you are just shifting the logic where you may not want it to be.
So we found a way to don't have to choose. So we found a way so we wait. Yeah, sorry. So we found a way so we don't have to do any trade-off. So the solution we found is to open a stream between the front end and the back end. So for example, server-side events. And so the back end can be charged in what to compute first and send it to the front end as soon as the data is available. So we get the best of the both worlds. We get slow latency, small overall runtimes, and the front end don't have to know anything about Kafka business. So let me show you some codes about that. So at Conduktor, when we're not using GraphQL, we use Tapir for REST, and I guess everybody knows Tapir. I don't need to explain about it. So just to say shortly, so Tapir is a library that allows you to have a descriptive to describe your endpoint, and it will generate OpenAPI for you, and you can predict with a lot of backend like HTTP4S or HTTP or whatever you want. And so it's really easy to use, and we found moving from a REST endpoint to a SSO endpoint is really easy. So you see here when we say out, we just send the out to JSON body to server-side event body, and that's done. And before we had a logic, so the logic was producing an effect with the data to send to the front end. Here we have a logic that produces a stream simply, and the stream is what's going to be sent to the front end. So in this stream we have a sample Scala ADT, very easy. So it's info for topic info, and we have 2 specific subtype on this ADT that is complete, that the backend sends once it knows there is no data to display anymore on the front end. And the first one, topics, where we send the list of all the topics in the cluster, so the front end can prepare its table. But those 2 subtypes, the other types are really simple. They just associate a topic name to a given metadata, and we can send the topic metadata as soon as they are ready easily with that. So I show you the endpoint definition, so I'm going to show you some code about the logics. So here there is stream things, so I'm not going to speak about that, it's not really important, it's just sometimes it's more easy to work with queue for case than stream, I'm going to explain why. So stream things create a queue of info, and we push elements on this queue, and it just make a stream of it. And the advantage for having a queue is we can use the same logic from the previous slides, where we compute everything at once and send everything at once to the front end. Here, the only difference is like all the time doing our for comprehension, all the time we have a data that now is interesting to the front end, we can like tap it and send it to the queue. And we have a normal like for comprehension, really easy to write and to understand. So Matthieu, what's the key takeaway about that?
Yeah, if we take a pause, what did we learn at that point is that, with streaming endpoints, we don't have to do trade-off. So it's quite a good thing, in my opinion. The other thing is that it has no real impact on the front end. It's quite straightforward for a front-end developer to just get some information as JSON and display them. So it's really easy to do. And finally, as you can see before, it's just a matter of having tap and queuing things. So it's really simple to adapt some backend code to do streaming.
But yeah, so we could like finish the talk here, but sometimes you know to go further than that. So let's go back to the business, you know. So the user will arrive to the topic list, but he won't stop here. So either he will click on topics to see some metadata, or we will just like simply go to the next page, you know. And so if you want to have like the smallest latency, you will maybe like think about some trick about that. Say, okay, maybe the front end like can start open the stream for the second page before the user actually clicks on the first page, and will be happy about that. But it's not the best, because if you open a new stream, then we start a new computation from the beginning. And if you go back to this slide, to this graph where I explain you all the code we need to Kafka, and you think about it, there is some metadata from Kafka that are common to all the page of our topic list. So in the ideal world, we want to keep them on the backend side to not have to call again Kafka for that. So we now have a reason to have a stateful backend to provide the best API. But if you speak about stateful backend, there is like some question, you know, like, so that means you have to keep a state between requests. That's complicated, you know, how do you do that? And if you speak about states, and you speak about lifetime, you know, how do you manage the lifetime of your state, or you make sure this state is created and destroyed properly?
So the solution we found to that is to use a WebSocket between your front end and your back end, and to bind the state to this WebSocket. So you open the WebSocket, you can send a query, and it will start building the state, and then the next request will be served by the same, with keeping the same state. And if you want to just have fresh data, you restart a new WebSocket, or you can even have a verb for that, a command for that. If we look internally at how it works, if we zoom on the stateful service, it actually has two kinds of inputs. The first one is an outside command, as we saw in the previous slide, but it's also response from Kafka in our case. So basically, we have command coming in, and if we decide that we need to query Kafka to have some new information, you will just ask him to send us a response in our input channel. And then on any kind of input, we'll compute what is relevant to push to the front end, and we send it back to this output channel. So
let's now go deeper inside this stateful service, and then we make it work. So I'm going to present this stream operator from ZDO stream called Matthieu. So it's an operator that allows us to have stream and state, and to have a stateful stream. So Matthieu, it's an operator, so it takes an input stream like every operator, of course, and it takes a function, and a state, initial state. So the initial state here is S1, and the function should be able to take a state and an element from the input stream and compute a new state and an element from a different type to put on the output stream. And so the first element of the input state is going to be combined with the initial state. We're going to use this function, get a new state, get the element to output, put the element on the output stream, and the new state that we compute is going to be matched with the next element of the stream. And so we can use this function, get a new state and a new element, and so on and so on. But that's not enough in our case, because if you remember from the previous slide where you saw like so the stateful service, the front end, so the WebSocket on the front end, we have to send requests to Kafka when we compute a new state. And so if you have to send requests to Kafka, that means we need to communicate with the real world, so we need to have an effectful computation. So in reality, we are going to use map_ZIO. That is almost the same function than the one I explained to you before. The only difference is f now is stateful, and you have to produce an effect giving the new state and the new element. And so for us, it's convenient because in using this effect, we can also communicate requests to Kafka.
Okay, so I propose to go through a step-by-step execution of how this actually works. So here you have a command that is subscribed as the first command sent by the front end, and then you have a state in which you store the fact that you are actually loading topics and broker IDs. And in the pending request, you have these two requests. There's nothing to send to the front end yet. And then comes the topics name from the pending request to Kafka. So you are able to update your state with these new topic names, and then you will mark these topics are we are loading description from them, so we keep that information in the state. And we decide at that point that we need the description, so we send a new request to Kafka. And as we already have names and it's relevant for the front end, we push the topic names to the front end right now. Then we have broker IDs, which was the other pending request, and so we do exactly the same. We keep that in state. We issue a new request to Kafka to have the log there. The only difference is there we don't care about exposing the broker IDs to the front end, so it's this information stays in the state, but there's nothing to output to the front end at this point. And then we get the topic description, so at that point we know how many partitions there are, the replication factor. We are able to compute some things based on that and send it to the front end. And also we know which partition we should ask offsets for. That will help compute the size of each partition. So I will stop the step-by-step execution at this point, but I think you figure out how all this work with the state, request, and output.
So yeah, this step-by-step execution might sound very specific to Kafka for you, but the idea to explain that is to try to figure out a general pattern that you can extract and use whatever your business logic is. And so the general pattern we extract here is, so you got the front end that sent to the stateful service, so map_ZIO is send some commands. And using this command, we take the state and we apply the command on it. It gives us a new state. And with this state, we can compute in a pure way a state diff. And we have another pure function that is business specific, that using this state can determine if you can send data to the front end or not. And another pure function that with taking this state will compute the request we need to send to Kafka. So that's the global logic here. You can memorize about that. And the smart trick is, as we say before, Kafka will reply as command to, and we have kind of a loop like that. So let me show you some code about that. So this is the code that do the same as the graph before. So in the function input here, the Q is data only from the front end. And in this code, command is named impute, and in reality we have two kinds of impute. So we have impute from the front end, they are called command. And then after, in the response queue here, we have input that come from Kafka. So here we create a queue, that's the reply of Kafka, and Using those two queues, we create two streams, and we merge them together in one stream that will give command either from the front end, either from the Kafka. And then, as you can see, I can use a map accum.io that I explained before, using initial state. And then I can do my pure computation about the new state using the state. I can compute the new request, and I can compute the info to send to the backend. So all of that are pure function, and there is only one effect, execute request, where I send the request to Kafka.
Okay, so what did we learn at that point is we combine the state, the lifetime of the state to the lifetime of the stream. It's quite easy to do with ZO stream. And also our business logic can be cut in 3 parts. The first one being the update state that gets either a command or a response and goes to the next state. There is the second function that goes from state to request that allows us to make the state evolve by querying Kafka in our case, but it could be anything else. And a third state that just takes the 2 states or a state diff and goes to info being what you actually send to your view. And it's, yeah, the generic way that we found work. When not to use that, obviously it's not that simple to implement. So it has to be used in the right situation. If your data source is low latency already, there is no point having that complication. So yeah, that's a case where you don't want. And also, there's we showed 2 things, the stateless streaming and the stateful streaming. So don't use state if it doesn't add enough to your application, because it's yet again increase the complexity of the code. So yeah.
So what's the conclusion of our presentation? So firstly, again, stream, we often don't think of them first, but they're like wonderful tools, and they solve a lot of problems. So try to stream all the things.
The second takeaway is streams can be stateful, so it's not something that is obvious. And yeah, I think it's powerful to combine state and stream, actually.
And lastly, because of Kafka, Scala, and Tapir and the wonderful ecosystem and ZIO, doing something like that is boringly easy. Even a cat could do it, you know, IDT, stream, WebSocket. I think we convince you it's easy. By the way, Conduktor is hiring, so if you like working with Scala and ZIO and Scala, just reach to us.
Yeah, and all the code is hosted there. It's much more complex, and there's much more in it than what we showed. There's also a front end written in Elm-Lang. If you are interested in how it works and how it behaves, just go there. It actually is really fast with the streaming one. You can compare. It's interesting to run. And yeah, I don't know if there are questions, but yeah, if we have time for a question or not, let us see. Otherwise, just come after, ask questions.